Hello friends, it is lecture number 5, lecture number 6. In last lecture we saw the problem based on heat of neutralization. Today here we are going to continue same problem which is based on heat of neutralization. The problem number 2 is here, calculate amount of heat released when, again there are two conditions are given. First condition is 600 cubic centimeter of 0.1 molar HCl mixed with 200 ml cubic centimeter of 0.2 molar NaOH. So here 0.1 HCl is given and 0.2 NaOH is given, and the volumes are given here 600 centimeter cube or 200 centimeter cube. So 1 centimeter cube is equal to 1 ml. So that means here is a 600 ml, here is a 200 ml. So in simply the 600 ml of 0.1 molar HCl mixed with 200 ml of 0.2 molar NaOH. So when these two acid and base mix together, there is a neutralization reaction. So how much amount of heat is released during this mixing? Simply you already know. So any 1000 ml 1 molar HCl is equal to 1 mole of H plus ion. So here the volume is given 600 ml and the concentration is given 0.1 molar HCl equal to how many number of moles of H plus. So here we calculate it first. So here it is calculated as 600 into 0.1 molar upon there is a 1000 ml. The answer will be 0.06 mole. 0.06 mole of H plus. Second, when 1000 ml 1 molar NaOH is equal to 1 mole of OH minus ion. Here the volume is given 200 ml or 200, you can write here simply 200 centimeter cube, and what is the concentration is given here 0.2 molar NaOH is equal to how much? So here simple 200 into 0.2 upon 1000 is equal to 0.04 moles of OH minus. Okay, so first of all we convert the given solution into number of moles. Then you can see here both has different concentrations of H plus and OH minus. So H plus concentration there is a 0.06 mole and there is a OH is 0.04 mole. That means out of 0.06 mole of H plus, only 0.04 mole of H plus neutralized by 0.04 mole of OH minus. So remaining 0.02 remains unreacted. So here only 0.04 mole of H plus neutralized by OH minus. That means you already know when 1 mole of acid base neutralize produce how much amount of energy? Minus 57.1 kilojoule. So here the number of moles are how much? Only 0.04. So 0.04 is equal to 0.04 into 57.1. So the answer will be here 2.284 kilojoule. Answer is 2.284 minus 2.284 kilojoule is the energy which is released when these are mixed together. Come on the second condition. Here the volume is given for H2SO4 is 250 centimeter cube, means is equal to 250 ml. Second, the NaOH instead of NaOH there is another base is given is KOH. KOH has the volume 400 centimeter cube, that means 400 ml. The concentration of H2SO4 is 0.2, concentration of KOH is 0.5. We solve same as a last example for like this one, but the something is changes here. What? The heat of specific heat of water is given, and here we find out the calculate the rise in temperature. So this is the same as the last problem, last lecture problems. So first calculate the energy evolved. Once you know the energy evolved, here you know the mass, you know the specific heat, you can calculate rise in temperature. Okay. So first we are going to calculate energy evolved during this mixing. So here 1000 ml 1 molar H2SO4 has 1 moles of H plus. And you know H2SO4 is diabasic. We multiply the number of moles into by 2. Here how many ml? 250 ml or 250. You can use 250 centimeter cube. What is the concentration? 0.2 H2SO4 is equal to, so 250 into 0.2 divided by 1000, but it is a diabasic, so we multiply here again 2 divided by 1000, and answer is 0.10. The answer is 0.10 moles of H plus. Okay, it is the first. What it is the second is 400 ml KOH. So 400, you can use ml or you can use centimeter cube, both are same. Before that, for 1000 ml 1 molar KOH is equal to 1 mole of OH minus ion, but here the volume is given 400 ml and concentration is 0.5 is equal to how much? So here 400 into 0.5 divided by 1000 is equal to here 0.20 moles of OH minus ion. So you can see here the concentration of H2SO4 and concentration of KOH is different. The number of moles are different. KOH has more number of moles as compared to H2SO4. So only the H2SO4 out of total 0.20 moles of KOH, only 0.10 used to neutralize the 0.10 mole of H plus. Means here 0.10 moles are unreacted. So the heat is evolved. How to calculate? So you can write same as a out of 0.20 moles of OH minus, only 0.10 mole are neutralized. So 1 mole of acid base neutralize, how much energy neutralized? The energy release is minus 57.1 kilojoule heat is evolved out. So here for 0.10 is equal to 57.1 into 0.10, and the answer is minus 5.71, minus 5.71 kilojoule is the answer. Minus 5.71 kilojoule is the answer. So once we know the energy evolved, then we can calculate the rise in temperature using the formula, and you already know the formula is Q is equal to M into S into delta T. M means mass, S is specific heat, delta T means change in temperature, means rise in temperature. Rise in temperature. So here we have M is equal to, the mass is 250 and 400. So 250 plus 400 is equal to 760, 750, sorry 650 centimeter cube, or it is a converts into, you can into gram. Specific heat S is given 4.18 joule per Kelvin per gram, and delta T we are going to calculate. We have the Q, so Q is equal to, already find here, minus 5.71 kilojoule, or 5 minus 571 joule. 571 joule, because here the specific heat is given in joule. So we put all the values here. So minus 571 is equal to, mass is given 650 into specific heat is given 4.18, delta T means change in temperature, we are going to be calculate. So delta T is equal to, this goes to divide here, so minus 571 upon 650 into 4.18, the answer will be here, sorry, it is just 5710 when we convert into kilojoule into joule. So answer is 2.10 degrees Celsius. 2.10 degrees Celsius is the change in temperature. During this mixing. So it is all about there are two problems which is based on heat of neutralization. Secondly, after that we are going to discuss some terms, some different types of energy or enthalpy which is used in chemical energetics. Okay. Okay. So next point is different kind of heats or enthalpies of reaction. Means up to this we saw the heat of combustion, heat of formation, and heat of neutralization. So heat of formation means what? When 1 mole of substance is produced at standard temperature and condition, the heat is heat of formation. When 1 mole of substance is burned and to produce the product is the heat of combustion. And when heat of neutralization means when 1 mole of acid and base are neutralized together, release the heat is the heat of neutralization. A part of these three heat of or energies, enthalpies, there are other enthalpies are used in chemical reactions. The first enthalpy which is used, the heat of solution. Heat of solution. Already you know what is a solution? It is a mixture of solute plus solvent. And basically solute present in smaller amount and solvent present in large amount. It is a homogeneous mixture. So depending on solubility of the solute and nature of the solvent, is it 100% homogeneous or not? But it is the solution. What is the heat of solution? Heat of solution means when 1 mole of solute is dissolved into solvent, that time the heat is produced, heat is evolved, heat is released is the heat of solution. But the condition is, it is a maximum heat which is evolved when the 100% 1 mole of solute is dissolved into given volume of the solvent. If we add further volume, further addition of solvent, there is no change in heat because 100% heat is evolved out. Suppose we consider 10 gram solute dissolved into 10 ml. It is possible only few of the solute molecules are dissolved. But if we add the 1 or 10 gram of solute into 1 liter of solvent, it is possible 100% solvent will be dissolved. That means the heat which is evolved out when 1 mole of the solute dissolved into maximum amount of solvent. And if we add the further addition of solvent, there is no change in heat. That means 100% solvent dissolved and their heat is released is the heat of solution. And this heat of solution is, there are two types. integral heat of solution and differential heat of solution. In integral heat of solution means if we use the specific amount of solute dissolved into a specific amount of the solvent, the heat is evolved out is the integral heat of solution. So here we know here the how much amount of solute is taken and how much amount of solvent is taken to make the solution, and here the specific temperature condition, temperature and pressure condition will be maintained here. So it is an integral. It is a specific amount of solute when dissolved into specific amount of solvent is the integral. But what is the differential? It is against temperature pressure conditions when we dissolve the solvent into a specific amount of solvent. That time when the number of moles of solute dissolve into number of moles of solvent. So how many number of moles are dissolved into how many number of moles of solvent? So it depends on number of moles of the, so basically differential heat of solution is calculated per mole of the solute and per mole of the solvent, and it is represented as a delta H1. It represented as a delta H1 because here is the number of moles are used. So this is about the two terms, integral and differential. So here specific amount of solute and specific amount of solvent is important. Here the heat is calculated, heat is considered by per mole of the solute dissolved into per mole of the solvent. So it is depends on number of moles, and here it depends on specific amount of solute and specific amount of solvent. So this is all about the differential and integral. Suppose, for example, suppose we consider KCl. It is a solid. When we dissolve into water, it is aqueous. What happened here? KCl, it is aqueous. So it is a solution. Here is the solution, right? So KCl is simple salt. Aqueous means here is the solvent is water. KCl is the solute. So solute plus solvent gives solution. So that time the heat is released, and the heat is released, the experimental value is minus 18.6 kilojoule. It is a plus. Heat, there is a plus sign means what? When this salt is dissolved, that time heat is absorbed. It is absorbed. So in some reactions, in some solution, heat of solution is not always negative. Heat of solution may be positive as well as negative. Positive means what? If there is a positive sign, that means heat is absorbed. If there is a negative sign, that means heat is evolved. So if you see, if there is a positive value, positive sign, that indicates the heat is absorbed, the reaction called as endothermic reaction. And when in any solution, when you make any solution, that time heat is released, there is a negative enthalpy, that means there is a heat is evolved, it is the exothermic reaction. There are two examples and you can try at home. If you take the lime and when you dissolve into water, if you touch the container, it becomes very hot because water is boiled. It is a highly exothermic reaction. But urea and सगळ्यांच्या घरी urea असतो. If you put urea into water and if you touch the container becomes cool. Means what? Heat is absorbed. So when you dissolve urea, the reaction is endothermic. When you dissolve lime into water, the reaction is exothermic. Heat is evolved, heat is absorbed. These are the heat of solutions. त्यांना आपण म्हणतो heat of solution. The second term which is used is heat of hydration. Second term is used heat of hydration. Heat of hydration. Hydration means what? Water. React with water. When any solute or any salt, when it react with water, means any anhydrous salt, when mixed with water, converts into or react with water, not mix with water, mix with or react with number of moles of water. Here is not a solution. Solution is different kind. Water is acts as a solvent there, but here water is not acts as a solvent. When anhydrous salt react with some number of, or how many? 1 mole. When 1 mole of anhydrous salt when react with a particular number of moles of water, that time the anhydrous salt convert into hydrous nature. Converts into hydrous nature. That time the energy involved here, the energy is evolved out, is the heat of hydration. Heat of hydration. For example, if we consider copper sulfate, it is anhydrous, and when it react with water molecule, 5 water molecules are react with 1 mole of CuSO4, it converts into CuSO4 dot 5H2O. So this is the hydrous form, there is an anhydrous form. So when there is a hydrous H2O molecules are react or comes in contact with CuSO4, so anhydrous salt converts into hydrous salt. That time the heat is evolved. The heat is evolved or heat is present. The heat is called as, or the heat is changed, is the heat of hydration. So simple, the definition is the amount of heat change when 1 mole of hydrous salt combined with the required number of water molecule is called as heat of hydration. It is the heat of change when 1 mole of hydrous salt combined with a required number of water molecules and convert it into hydrous form is the heat of hydration. Is the heat of hydration. Secondly, after that, the term or another enthalpy which is used here is heat of fusion. Heat of fusion. What is a fusion? Fusion means basically solid converts into liquid. Solid converts into liquid. So it is a change in heat when 1 mole of substance or solid converts into liquid phase. Converts into liquid phase at its melting point. At its melting point. What is the melting point? When solid converts into liquid is the point. It is not a definition. It is just a observation. What is the melting point? Solid converts into liquid. So fusion is different. Near the melting point, near the or at the melting point or close near the melting point, the state is fusion state. Okay. So that time the energy which is required to convert 1 mole of solid into 1 mole of liquid. So that time the heat is changed, the changing in heat is called as heat of fusion. When substance is fused, not a 100% converts into liquid, but it is the fused state or near about the melting point state. So definition is when the change in energy or change in heat when 1 mole of solid is converts into liquid phase at its melting point. At its melting point is the heat of fusion. So, for example, if H2O solid, H2O is the solid, the solid H2O means ice. Okay, when it converts into H2O in a liquid state, that time some energy is required, the energy which is here. So H2 is solid, is the ice, the energy is very low. We need the temperature, we rise the temperature, we giving the energy, and then it converts into liquid. So melting of ice into water, the state is fusion state, the process is fusion. That time how much energy is there, how much heat is changed is the heat of fusion. Okay, next is heat of sublimation. Before that, heat of vaporization. Heat of vaporization. What is a vaporization? Vaporization means when liquid converts into vapor state or gaseous state. So basically liquid to vapor means gaseous state. So it is a change in heat when 1 mole of liquid 1 mole of liquid converts into 1 mole of vapor or its gaseous state at a gaseous state. So here what happen, the liquid converts into gaseous, the process is boiling point. पण त्याला काय म्हणतो boiling point means it is a change in heat when 1 mole of liquid converts into gaseous phase at its boiling point, at its boiling point. Okay, so boiling point means what? And you know the definition of boiling point and melting point. Okay, and it is for your homework. Write down the definition of boiling point and melting point. Okay, you can write on page. Okay, and submit in Google Classroom. So it is the heat of vaporization. The heat change when 1 mole of substance, liquid substance, converts into gaseous state. After that, last term which is used, sublimation. Sublimation. It is very important another thing. What is the sublimation? You already see the examples. So you know the camphor which is in our home. So camphor, when you put open, after some time it is evaporate. Means what happen? Camphor is solid, but after some time it is disappear. That means it will be converts into gaseous phase. Means when any solid converts into gaseous state, called as sublimation. So it is a change in heat when 1 mole of solid converts into gaseous phase or vapor phase, called as heat of sublimation. But important point is here, the solid which is directly converts into gaseous state without going to liquid state. Basically we know the solid converts into liquid, then liquid converts into gaseous state. Okay, but some substances has higher vapor pressure, and when we provide some energy, they directly converts into gaseous state. For example, naphthalene, for example, camphor. So these are the substances which are directly sublimize solid into gaseous state. Okay, so naphthalene is the example. Iodine, you know iodine, when you just shake it, iodines, it converts into vapor states. Okay, so this is the sublimation. But here, so basically solid converts into liquid, converts into gaseous, and here the another thing is direct. So this is the diagram. It is a representation. When solid directly converts into gaseous, we call it sublimation. When solid converts into liquid, we call it fusion. We already see. When liquid converts into gaseous, vaporization. So when this conversion happens, 1 mole of solid converts into liquid, it is a heat of fusion. When 1 mole of liquid converts into gaseous, it is a heat of vaporization. And when 1 mole of solid converts into 1 mole of gas into gaseous, there is a heat of sublimation. So three energies which are used. And what is the heat of hydration? Suppose any metal which is present in gaseous state, isolated gaseous state, N plus 1 is the oxidation state. Here H2 is there. So X number of H2 is present. It converts into M, H2O, M plus N. This is any oxidation state. Here is the N X number of waters are attached. So that time change in energy. The energy is released heat of hydration. When any solid, when it combined with a required number of water, but the nature is here, solid is anhydrous, and after it converts into hydrous form. So how many required numbers will attach to this? It depends on their ability. So every anhydrous solid has different ability to attach the number of water molecule. So anhydrous solid, when react with a particular number of waters or combined with particular number of water, that time there is a change in energy. The energy is called as heat of hydration, heat of sublimation, heat of fusion, heat of vaporization. So this is all about today's lecture. In next lecture, we are going to solve the problem which is based on the another topic. It is a bond energy and bond enthalpy. Okay, so we stop here today.